I'm converting 215 to radians. I'm just going to put that over 1 and multiply it by, I need degrees on bottom. I need them to cancel out. I need the degrees to cancel out, so I need degree on bottom, which means I'm putting 180 there, and I'm putting pi on top. That's going to give me 215 pi over 180. That one should reduce, because I forget how many go in it. That will reduce down to 43 over 36. Now pay attention to what I'm about to say. Don't ever, when you're approximating radians, leave the pi in there. The only thing you'd ever approximate would be that 43 over 36. So all you do is you'd plug 43 over 36 in, get a decimal, say it's 1.3, and go, the answer is 1.3 pi. When you're in radians, leave pi as best as possible. Otherwise, you run into this situation where you're like, is it pi or is it degrees? All right, so leave your pi in there. Don't, unless I specifically say you have to approximate it to the nearest tenth, don't ever plug this in your calculator. Leave the pi in the answer. All right, negative 22 degrees. Once again, follow the exact same structure. I need the degrees to cancel out, so my 180 goes on the bottom, and the pi goes on top, which is going to equal negative 22 pi over 180 degrees. But the degrees have already canceled out, so I just have the pi there. I know 2 goes into them at least once. We have negative 11 pi over 90. That looks like as far as we can go. Radians, you have 2 options. If you're struggling with conversion, then do it the first way. And that is do our normal conversion, where we put pi on bottom and 180 on top. I want degrees out, so I'm going to put degrees on top. That means the pi's are going to go ahead and cancel out. And since we have degrees, this would be something I plug in my calculator. I do 14 times 180 divided by 9. Was that like 260 or somewhere around there? 280. The alternative is you could just plug 180 in for that pi. You could have just did 14 times 180 divided by 9. But don't do that unless you're very comfortable with converting between stuff. How do I know 7 is a radian? There is no degree symbol. Get used to looking for that. Because this can just be a section that says convert to radians or degrees. And you have to decide which version you need. If there's no degree symbol, either I messed up or it's a radian. If you're not sure, ask a question. Say, this is missing a degree. Do you want it to be radians, Mr. Fabian, or did you make a mistake? All right, so since it's radians, this is the harder one. There is no pi to see cancels out, so you just got to remember pi goes on the bottom and degrees are on top. I'm going to end up getting degrees out. Now, because it's degrees, you want to plug this in your calculator. So you want to do 7 times 180, and you're going to divide by pi, and that should have came out as A401.1 degrees. Questions on the bell work?
Not what I did at all.
But you end up with the right answer. Well, if it works, it works. Questions on the bell work? Cool. Then let's ask questions on the homework. Knowing that this is the last time we're going to talk about the homework and those types of problems until we get to the test, which isn't next Tuesday, but the Tuesday after. So this is kind of the last time we're going to talk about these types of problems until then. What questions do we have? This is a super, super important lesson. This is us building the rest of that unit circle we're going to use for the rest of this mark period. And if you don't understand how to read that, you're going to really struggle from here on out. So make sure you really pay attention today and how you read this and what those numbers are referencing to. We already know what degrees and radians are. Remember, degrees and radians are the same thing. They're measuring how far you turned in a circle. That's it. They mean the same thing. It's like feet and meters. So don't go, Mr. Pavian, this problem has degrees in it. Is it different? It's always going to be the same. Degrees and radians are just different ways of measuring the same exact thing. So if I ask for the sine of 30 degrees and the sine of pi over 6, I'm asking the exact same question. I'm just using different measurement totals. So the answer is going to be the exact same. So In geometry, we learned something called SOHCAHTOA. SOHCAHTOA told us how to find values when I have a specific angle of a right triangle. So this has to be a right triangle. And SOHCAHTOA are ratios, so I could actually find that degree measure. Or I could take that degree measure to find those particular ratios. So SO stood for sine equals opposite over hypotenuse. Ka, adjacent over hypotenuse. TOA, opposite over adjacent. So as soon as I have a right triangle and I pick an angle, call it theta, I'm going to immediately know that side that's straight across from it is our opposite side. The side you have to do kind of a curly Q thingy there to get to would be your adjacent. In other words, your adjacent is the one formed with the angle. So my angle forms the adjacent side, and the opposite side is directly across. If I asked you for the sine of that angle, say that angle is 30 degrees, I might say, what's the sine of 30 degrees? And you'd have to use your sides to name what those values are. So the sine of theta is going to be so that would equal our opposite value over our hypotenuse. And those would just be numbers. It might be 3 over 4, it might be 5 over 6. Cosine, on the other hand, will be your adjacent over your hypotenuse. And finally, tangent. Don't worry about tangent. We're just doing sine and cosine today, but tangent would be opposite over adjacent. But we could forget that tangent exists for a few lessons. We're just focusing on sine and cosine. Now, let's skip that for right now. Let's move on to trig functions on the unit circle. A unit circle is a circle with a radius of 1. A unit means 1, so a unit circle has a radius of 1. That's important. Centered at the origin. It's a useful tool to compare angles in degrees and radians and finding exact values of the 6 trig ratios. So the goal of the unit circle is that you don't need your calculator to find specific values of sine, cosine, and tangent. So I could say something like the sine of 45 degrees is obviously square root of 2 over 2. That way you don't have to plug it in your... It's not obvious. Don't think... Wasn't obvious, but you'll learn it today. These are things you're going to have memorized, so you don't need to plug in your calculator. You can get an exact value out. So it says that the unit circle is a circle with a radius of 1 that's centered at the origin. So our unit circle is going to look something like this. Oh, that is not as good a circle as I did in the first class. Sorry.
Jake, you should copy and paste that.
I should. I'll just go back. I have a circle tool, but it actually makes it harder because you have to get it perfect, and it never gets perfect. Okay, that is my unit circle. So when I look at that unit circle up there in the front of the ruler, that's what's here. I want to point out the fact that since this is just on an xy plane, we actually know all 4 of these points. So this point right here, the coordinates of that point would actually be, oh, that's terrible. This would actually be 1, 0. Where if I went straight up, that would be the point 0, 1. If I went way to the left, that would be the point negative 1, 0. This right here would be 0, negative 1. And if you can see my unit circle up here, you can see those key points are on there. So those aren't necessarily ones you have to have memorized. You just have to recognize what the unit circle is, and it's drawn on the xy plane. That this is the coordinate. Go right 1, up 0. Go up 1, left, right, 0. Those are your x, y values. Now we're going to get to the more important point. I'm going to draw a triangle on here. And you can draw a triangle anywhere on a circle. From the center to here is going to form a triangle. And that triangle is going to have a point. That point's going to be important, and we'll get to that. First of all, what's the hypotenuse of this triangle? So I'm going to say right now it's a right triangle. You know this. What is the measure of this? Well, it's 1. Any hypotenuse I draw on the unit circle will be 1. That's important. Now, what I want to point out is that red point that's up there. It's going to be some x, y value, right? We move right a certain amount, we move up a certain amount. X is your left-right movement. So x must come from this line here. I'm moving right x units. So I'm actually going to label this triangle with an x down here. X units this direction, y units up. So this length right here would be y. Well, now I have a triangle I can draw anywhere I want on that unit circle that has a base of x and a height of y that result in the point x, y. That's important because let's talk about the sine. And in fact, go back to that triangle. I'm going to go ahead and put a little theta right here because we're always talking about this angle. We're always talking about this angle. So let's say I asked you to find the sine of theta. Well, you're going to go back to SOHCAHTOA, and you're going to go, okay, SOHCAHTOA tells me SO, opposite over hypotenuse. Well, the opposite side of this is actually our y value. So that would equal y over, and the hypotenuse is always 1 on the unit circle. What that means is if I ask for sine of that angle, bless you, that's going to equal this y value. This point's y value is actually going to be your sine of that angle. So let's say this is 30 degrees. If I ask you for the sine of 30 degrees, you're just going to look for that y value, that 1/2 that's up there. Cosine of theta is now adjacent over hypotenuse. Our adjacent side is the length. It is how far right we go or left, depending on where we draw it. That will be x over 1, which just equals x. So when you look at the unit circle, do you see all those, for those that can actually see my unit circle, can you see all those x, y values? They're numbers, they're paired off numbers. We have first number, second number, and usually we look at it as x and y values. I want you to stop thinking of them as x and y values. Instead, I want you to think of them as being your cosine and sine values. Did you have a question? Or you just, okay. I want you to think of those as being your sine and your cosine values. The quicker you understand that, the easier this is going to be. All right, and down there is just exactly what I just said. Think of your x-y pairs as being cosine and sine pairs because they're equal to each other. Your x value equals your cosine of that angle, and your y value equals the sine of that value. If that doesn't make sense, it's okay. We're going to go through it a little bit more here. We'll see if this makes a little more sense if that one did. Let's look at quadrant 1 of our unit circle. Quadrant 1 of our unit circle. We're going to go ahead and put all of the values on there. We already know 2 of them. Whenever a unit circle, remember this is just an xy plane, so this is 1, 0. Doesn't go up or down, so that's 1, 0. And the one that's way up there, my x value is 0, but it does go up 1, so it's a point 0, 1. Now I'm going to note that we're going to have 3 different triangles. I'm going to have one that's 30 degrees. I'm going to have one that, let's call it 45 degrees. And then I'm going to have one that is 60 degrees. Notice those were the key degrees I told you to memorize. 30, 45, and 60. 60 would be the one that opens all the way up there. Maybe I'll actually move that 60 up there. I put those in kind of bad places. What is the hypotenuse of every one of those triangles? 1. The hypotenuse of every one of these triangles is 1. It's on the unit circle, so it's 1. Now, if you want to reach back to your geometry memory, 30 degree, 45, and 60 degrees, you just need to know one side, and you can find the other two sides. You don't have to worry about doing this in class. You just kind of have to have these values memorized. If you have a 30-degree triangle, that's a right triangle and a hypotenuse of 1, you are going to have a side that is square root of 3 over 2, and it's going to have a height of 1/2. So this height would be 1/2. This base would be square root of 3 over 2. If I have a 45, 90 triangle with a hypotenuse of 1, you're going to find your two sides are going to be square root of 2 over 2 and square root of 2 over 2. Because remember, a 45-degree triangle has two sides that are the exact same measure. It's an isosceles triangle. So this would have a base of square root of 2 over 2. It would have a height of square root of 2 over 2. So it comes to a point, square root of 2 over 2, square root of 2 over 2. Well, the nice thing is, if I have a 30, 60, 90 triangle, this one here is a 30, 60, 90 triangle. So these values will be the exact same, except they're going to flip places. Because the one across from the 30 degree and the one across from the 60 degree switch places. So that point is going to be 1/2 will be the base, and we'll have a height of square root of 3 over the deuce. And that is our quadrant 1. And I'm going to show you a really easy way to fill out these numbers that you don't have to have memorized. You're just going to memorize the pattern. Kind of like with radians, where you're like, okay, quadrant 1 has a 1. Quadrant 2 has 1 less. Quadrant 3 has 1 more. Quadrant 4 has multiply the base by 2 and subtract 1. We're going to have a nice little pattern. So you won't need to rote memorize these, but you'll know a pattern to them. And the cool thing is, in one of our upcoming lessons, you really only have to have this quadrant memorized. So the really important thing is actually right here. If you can get that down, you understand something, you can actually just use this one quadrant. All right, questions on any one of those values I came up with? Okay. Know them. Love them. They're awesome. Let's see what they're used for. If I ask you for the sine of 0 degrees, in geometry class, you take out your calculator and type in the sine of 0 degrees. We can't do that in pre-calculus. In pre-calculus, you need to have these values memorized. If I ask for the sine of 0 degrees, that's the exact same thing as sine of 0. This is your radian form. 0 means it's radians. So if I ask for the sine of 0 degrees or the sine of 0 radians, you're just going to go to your unit circle and find that 0 degree angle. Remember that 0 degree angle is this flat line here? Then you're going to look at these two values. One is sine, one is your cosine value. Now just a reminder from the other page. When you look at an ordered set of numbers, cosine comes first, sine comes second. So if I ask for the sine of 0 degrees, I'm going to find that y value, which is 0. I'm going to come back here and I'm going to say, well, the sine of 0 degrees is 0. I got that value memorized. I got it written down. What would the cosine of 0 degrees be then? What was that?
0.
It won't be 0. Look at that point again. Yeah. It's going to be 1. Because just remember, the 1 is your cosine value, Labib. The 1 is your cosine value. So, in fact, if you have your calculator out right now, type in cosine of 0 degrees and see what you get out.
1.
You'll get out 1. And if you type in the sine of 30 degrees, sine of 45 degrees, sine of 60, you're going to get all of these values out as well. So let's continue on. So our next one is find the sine of 30 degrees, but it says it also wants it in radians. What is 30 degrees in radians? Labib.
Pi 6.
Pi over 6. Yeah, awesome. Which means 45 degrees is going to be our pi over 4. Which means our sine of 60 is going to be pi over 3, because we only can have 6, 4, and 3. And the sine of 90 is going to be pi over 2. I'm going to go ahead and fill those in on the cosine, because we know degrees are going to stay the same. 30 degrees is still pi over 6. 45 is pi over 4. 60 is pi over 3. And cosine is pi over 2. Who can tell me what the sine of pi over 6 is then? Or, same thing as sine of 30 degrees. What is the sine of 30 degrees according to that unit circle that we just started drawing? Yeah, Theo just coming in and nailing something. Yeah. It's going to be 1/2. Because all I need to do is come back here and go, okay, 30 degrees, my sine value is 1/2. Find your y value for it. What is the sine of pi over 4? Yeah. It'll be radical 2 over 2. Thank you. What would the sine of pi over 3 be then? Someone on this side. This side of the room. Okay, yeah.
Radical 3 over 2.
Radical 3 over 2. Awesome. And let's stay on this side of the room. What would the sine of pi over 2 be? Yeah. It's going to be 1. Perfect. I want you to fill the cosine ones out if you haven't already. Go through the cosine ones and fill out what values those would be. Matt, do you have a question?
Are sine and cosine opposites?
Yes.
Okay.
It's nice that way.
Yeah.
If you know one, you absolutely know the other. In fact, when we fill out the unit circle, I'm going to fill out just sine, and I'll use that to fill out my cosine values. Yeah, it depends. It depends on if you get it or you don't get it. If you get what's going on, you can read it quickly. That'll be a quick homework. All right, Maggie pointed out a really good bit of information. 1/2 and square root of 3 over 2 kind of come in pairs. If one is 1/2, the other one's going to be square root of 3 over 2. So if I come down here, my cosine of 60 is 1/2. That means my sine is square root of 3 over 2. Square root of 2 over 2 always pairs with square root of 2 over 2. So if someone tells you the sine of something is square root of 2 over 2, you can go, oh, cosine is square root of 2 over 2. They go together. You don't even know what value it was. You would know it's square root of 2 over 2. 1 goes with 0. All right. You need to know this as well. You need to know all students take calculus. All students take calculus. It will tell you what's positive and what's negative and what particular quadrant you're in. So let's look at what's going on here. When you say all, you're talking about quadrant 1. Quadrant 1 means all trig is going to be positive. So that means sine and cosine are both positive. Students. Students tells you sine is positive. Everything else is negative. So you just have one positive. That's sine. That means cosine, tangent are both negative. All students take. We're in quadrant 3. Tangent's positive. Cosine, sine are negative. Finally, quadrant 4, calculus. Cosine is positive. Everything else is negative. It's going to help you when you fill out your unit circle, and it's going to help you when we start doing, and I won't get into that, but it'll help you later on. It's going to make your life so much easier if you can remember all students take calculus. Let's go ahead and fill out our unit circle together. I'm telling you right now, you're going to have a quiz that looks just like this. Everything's blank. That isn't up there. You got to be able to fill in everything. So what I'm going to do is we're going to start with degrees. Degrees, hopefully I had practice on it because I told you to memorize that the first day. So degrees, your major ones are, well, we got 0 degrees. Then we count by 30. It's just 30 and 15s. 30 degrees, 45 degrees, 60 degrees. Then we're back up to 90 degrees. 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and if you want to, you can put 3 60 underneath the other one. Not a line for it, but some people like to put that 360 on there. Radians. You can get ahead of me. You should be able to do this faster than me talking through it. So if you want to get ahead of me and try it, go ahead and put your radians down on your own. 0 degrees is the same thing as 0 radians. For radians, what are the 3 bases? There's only 3 bases we can use for radians that are the key ones. What are those 3 bases? Anybody know those 3 bases? Someone knows the 3 bases. I see people filling it in. What are the 3 bases? Yeah.
3, 4, 5, or 3, 4, 6.
3, 4, 6. Thank you. Thank you. All right, and for these, we're going to start with 6, 4, 3. So I'm just going to do my bases first. 6, 4, 3. Right here is going to be 2. So pi over 2. And then it's going to go 2, 3, 4, 6. Down below is just a mirror image. I'll put a pi there. It's just going to go 6, 4, 3, 2. And then we'll go 3, 4, 6. For quadrant 1, you're just going to have 1 in front of your pi. So it'd be 1 pi over 6, 1 pi over 4, 1 pi over 3. What happens in quadrant 2? What do we do to get to quadrant 2? Jacob?
1 more than the denominator.
Or, that's quadrant 3.
Oh.
Quadrant 2 is
1 less.
1 less. Yep. It's going to be 1 less. It's a smaller quadrant, so I think there's smaller numbers on top. So that'd be 3 pi over 4. I'd have 5 pi over 6. And then quadrant 3 would be 1 more, so it'd be 7 pi over 6. 5 pi over 4, 4 pi over 3. And then for our 4th quadrant, we're going to multiply our denominator by 2 and subtract 1. So 3 times 2 is 6, minus 1 is 5. 2 times 4 is 8, minus 1 is 7. 6 times 2 is 12, minus 1 is 11. If you needed to just strictly copy that off of your sheets, then you're not doing what you need to do. You could have a quiz on this tomorrow. And you need to get this part done because you had several days to practice it because we're going to add something new to it today. So tomorrow, the quiz could be fill in the entire unit circle. And you have to know it by tomorrow. So I'm going to do my key sine and cosine values first. This point right here is right 1, up 0. So that's going to be the point 1, 0. Straight up is going to be the point 0, 1. Straight left is negative 1, up 0, so it'd be negative 1, 0. And finally, straight down is going to be 0, negative 1. All right. Here is the good thing about sine and cosine values. They all have a denominator of 2. So if you can't do anything else, you can go ahead and just put fractions over 2. And at least you can get partial credit for that. Here's the way I think is the easiest way to remember this. I use sine as the sign that tells me where to go. So I use sine as the sign to tell me where I go. Sine is your second value. It starts at 0. I'm just going to count up. I'm going to go 0, 1, 2, 3. 0, 1, 2, 3. And then my cosine values will just be the opposite. So we'll have 1, 2, 3 coming down. So I use sine. 0, 1, 2, 3. And you're actually going to count down 3, 2, 1, 1, 2, 3, 3, 2, 1. So if you can get this first one done, you have the rest of the unit circle filled out. Now, everything has square root in the numerator. So we're going to have square root of 3, square root of 2, square root of 2, and square root of 3. So we've got to put square root bars on everything. You can even put square root bars on the ones if it helps you remember to put everything in the numerator under square root symbols. All right, if I'm using sine, I'm going to go ahead and just start these points. I'm going to go ahead and put my parentheses. I'm going to put over 2, over 2, over 2, over 2, and over 2, over 2. Oof, that was almost negative 2. Now, sign 0, 1, 2, 3, 3, 2, 1, 0. So you know you did it right if you get back down to 0. So once again, 0, 1, 2, 3, 3, 2, 1, 0. So I can just go, 3, 2, 1. Then I can fill in my cosine values, which would go 3, 2, 1 in the other direction. Put square root over everything. And now you have to remember something important. All students take calculus. Everything's positive. Students, sine is positive. That means cosine is negative. Cosine is your first value, so you do have to throw negative signs on your x value. So I'm going to do that in red, so you can see those negative signs. All students take, both will be negative in this quadrant. Calculus, cosine will be positive, sine will be negative. All positive, sine positive, all negative. Sine will be negative here. So let's go ahead and fill these values out. Well, if sine goes 1, 2, 3, 3, 2, 1, then sine's going to go 0, 1, 2, 3, 3, 2, 1, back to 0. So let's go ahead and fill those out. And remember, both of them will be negative here. So we're doing a negative 1/2. A negative square root of 2 over 2. And finally, a negative square root of 3 over 2. And then cosine are the flipped ones. So if sine went 1, 2, 3, I'm going to go backwards with 1, 2. If it right, 3 for the cosine, over 2, over 2, over 2. Put my square root symbols. And put a negative sign because everything except for tangent is negative in that quadrant. I'm going to say this a billion times. Sine goes 0, 1, 2, 3. Comes back down, 3, 2, 1. Counts back up, 1, 2, 3. It's going to end with 3, 2, 1. And it gets us back to 0. My advice is just fill out all your sines and then go back and do all of your cosines. Once again, if you're someone just copying stuff, don't think this way. You need to think this way. You need to find a way to memorize this stuff. It's really important. Okay, so we're going to count down. 3, 2, 1. Oh, let's put that 2 over 2. Put our square root symbols. And we do have to put a negative sign because sine is negative in quadrant 4. And then once you know sine, you should know cosine is square root of 3 over 2, square root of 2 over 2, and then we'll have 1/2. So by tomorrow, this needs to be memorized. But if you just take my hints, it really isn't that hard. Radians, quadrants, if you keep those specific, that's going to go really quick. Use your sign to tell you what values you have. 0, 1, 2, 3, 3, 2, 1. 1, 2, 3, 3, 2, 1. Yes?
Was there a blank one on this on the agenda page?
Yes. Yep. So print them out and try them. So Lviv asked, are there blank ones on the agenda page? Yes, there are. They're right on the top. I think I might even put some right in this 5.1a lesson right or 5.2a. Questions on the unit circle? All right. Let us go back to these 4 questions then. What is the sine of 135 degrees? Using that unit circle, what is the sine of 135 degrees? Yeah.
3 pi, you do 3 pi over 4.
We don't have to. Remember, the 3 pi over 4 is just another way. You could ask, what is the sine of 3 pi over 4? It's asking the exact same question.
Oh, sorry.
That's okay. So what is that going to equal, though? Yeah.
Square root 2 over 2.
It's going to equal the square root of 2 over 2. These both would be square root of 2 over 2. So what they're telling you with those degrees is 135 degrees. They're telling you to go here. So either they're going to tell you in degrees to go here, or they're going to tell you in radians to go here. And then we just got to find the sine value is always going to be your y value, so it's going to be the square root of 2 over 2. So when you see the sine of something or cosine of something, it should be, your answer should be one of these values. It's tricky at first, but then it gets easy. So what's the sine of 5 pi over 4? Jacob. Oh. You didn't think I was going to call on you?
No, it's negative 2, or negative radical 2.
Yeah, it's negative radical 2 over 2. How do I know that's in quadrant 3? How do I know 5 pi over 4? Just looking at the number, I know it's in quadrant 3. What tips it off that's in quadrant 3? Labib?
The sign is negative.
Not because the sign is negative. If I look at 5 pi over 4, how do I know it's in quadrant 3? Yeah. Because it's one more. I'm just saying if I go what quadrant's that in, you'd go quadrant 3 because the numerator is one more. Our next one, sine of negative 7 pi over 6. That's the harder one. Is negative 7 pi over 6 on our unit circle? Those values we just drew in. No. I don't want to use negative numbers. Remember in the homework where I took like negative numbers and I had to make them positive but keep them in the same place? What did I do to make sure they were in the same place but they were positive? Maggie?
You made them coterminal.
You made them coterminal. How do I find a coterminal angle with radians? Yeah.
You add 2 pi.
You add 2 pi. So we're going to find a coterminal angle. So we're going to find a coterminal angle. So we're going to have negative 7 pi over 6. And I'm going to add 2 pi. Well, I need a common denominator. So negative 7 pi over 6. Plus, to have 6 as a denominator, I need to multiply the top and bottom by 6. So that'll give me 12 pi over 6. And that's going to equal 5 pi over 6. Remember, that is a coterminal angle. Remember how in both homeworks we had to find the least positive coterminal angle? This is what it's for. It's so we can put it all on that unit circle we just created. So no matter what angle I give you, you can either add 2 pi, subtract 2 pi, add 360, subtract 360, and you will get to this. So that means negative 7 pi over 6 is going to be the same thing as sine of 5 pi over 6. And what is that value? Still got my answer? Or do you have a question?
No, I have it. It's 1/2.
It is 1/2. So once again, you go to unit circle, you find 5 pi over 6, which is right here. Sine is your second value, so it's 1/2. Really quick, the last one is just kind of an example of how to do these problems. Do you see this cosine squared 30 degrees? That squared is actually asking you to find this value and then square it. We just put it here so you don't accidentally square the 30 degrees. You're not like 30 degrees squared and then try to find it. So what this is actually showing you to do is it's actually telling you, well, find the cosine of 30 degrees and then square it. Find the sine of 30 degrees and square that. Well, the cosine of 30 degrees is square root of 3 over 2. The sine of 30 degrees is 1/2. Square root of 3 over 2 squared is square root of 3 squared, which becomes 3. 2 squared is 4. 1/2 squared is 1 squared is 1. 2 squared is 4. It equals 1. I'm telling you right now, that's not a coincidence. Sine squared plus cosine squared will always equal 1. We'll talk about that on a later lesson. Homework is on just one page. It's just reading the unit circle. Your actual big assignment is make sure you memorize that unit circle. All right. The homework shouldn't go long. If you have your unit circle and you understand what we did, the homework's going to go pretty quick. The worst thing you need to do is find coterminal angles. That's the hardest part.